Okay, this video is going to be talking about solving systems through elimination. And when you're solving systems through elimination, what you're trying to find are zero pairs. Now, what does zero pairs mean? Well, it's a pair of numbers that make zero. So, for example, 1 plus a negative 1 makes 0. 5 plus a negative 5 makes 0. What you're going to be looking for is one is a set with variables with either x or y. So you could say negative 3x plus 3x plus a positive 3x is equal to 0. That's a zero pair. It's a pair of numbers that makes 0. Okay, so let's solve this system here. Alright, so the first thing we need to do is see if there's a zero pair. And it turns out there is. You can see this negative 4x and positive 4x. That makes a zero pair. Now the elimination method is also known as the addition method. Okay, the addition method. And the reason for that is because what you're doing is you are going to take these equations and add them together. So, let's do that. So if we take, negative 4x plus 4x, that's going to make 0x. Alright, now let's take the y's. Negative 2y plus 8y makes a positive 6y. And then that's equal to, we have negative 12 minus 24 is negative 36. Alright, so then from there, we're left with this 0x, and all 0x is just 0. So really, we're just left with 6y is equal to negative 36. And we can then solve for y by dividing by 6 on both sides. And y is equal to negative 6. Okay, so once we get here, the next step is just like the substitution method. We're going to take this value and we're going to plug it in to one of our original equations. Alright, let's do that. So, I'm going to do it off to the side here. We would have negative 4x minus 2 times y, and y is negative 6. So times a negative 6 is equal to a negative 12. And now we need to solve for x. Okay, so let's see here. We have negative 4x, and then plus 12 minus a negative 2 times negative 6 is positive 12 is equal to a negative 12. Subtract 12 on both sides. Negative 4x is equal to negative 24. Notice we have a zero pair here. Alright, now let's see here. And then the last step would be divide by negative 4 on both sides, and x is equal to positive 6. So, when x is equal to positive 6, y is equal to a negative 6, and our solution is when x is 6, y is negative 6, and so it's that point at 6, negative 6. Okay, so there are times where you won't have a zero pair, and you need to end up making one. So let's just go over that. I'm not going to solve them, but I am going to go over how to make the zero pairs. So let's start out with this set of systems here. We have negative 2x minus 9y is equal to a negative 25. And a negative 4x minus 9y is equal to a negative 23. So, notice that there's no zero pairs. In order for you to have a zero pair, you need to have something plus the negative of that something. And that would make 0. Well, we have almost a zero pair. If you notice, we have negative 9y and negative 9y here. It would be really convenient if one of those was positive. Well, we can actually make it so. And what we would end up doing is multiplying this whole equation by negative 1. Essentially, we're multiplying each side by negative 1, but I kind of do this for simplicity. So, from there, you just distribute, and you would solve. Okay, so a negative times negative 1 times negative 4 is a positive 4. Okay, and I'm going to write it up here. So positive 4x. Negative 1 times negative 9y is a positive 9y. And a negative 1 times a negative 23 is just a positive 23. And so now we've just rewritten it to have these two equations. And notice now we have a zero pair here. And we would solve just like we did the first one. Okay? So let's try one more. Let's try two more situations. So let's say we have a negative 7x plus y is equal to a negative 19. And a negative 2x plus 3y is equal to a negative 19. Well, we don't have a zero pair, but we can make one. Notice that we have 3y and just y. So in order to make a zero pair here, this thing needs to be negative 3y. And we can actually do that by multiplying the entire equation by a negative 3. Okay, so that would mean that when I rewrite it, and I'm just going to rewrite it, this time I'm going to rewrite it below. I end up rewriting it where I think it's just convenient. So we'd have negative 3 times negative 7 is a positive 21x. Negative 3 times y is that negative 3y. And negative 3 times negative 19 is a positive 57. Okay, and you could just plug that into a calculator and figure that out. So now we're left with this equation here, this system. And notice we have a zero pair, and we would just solve like we did from the beginning. Okay, let's do one more. Okay, making a zero pair. So let's say we have 3x minus 2y is equal to 2, and 5x minus 5y is equal to 10. And we don't have a zero pair, but we can make one. So just like before, when we ended up multiplying one of the equations by some number, we can end up doing that to the same, or to both equations. So let's say I want to try and make my x's a zero pair. One's got to be positive, one's got to be negative. So I'm just trying to think about what could I multiply this by and what could I multiply this by so that they would make a zero pair. Well, if you just kind of go by the numbers you're given, I'm going to multiply this one by a negative 5 and this one by a positive 3. In which case, I'm just going to rewrite those below. I have negative 5, right, distributing through. Negative 5 times 3x is a negative 15x plus 10y, right, negative 5 times negative 2, and equals negative 5 times 2 is a negative 10. And then I'm going to distribute these through. 3 times 5x is 15x. 3 times the negative 5 is a negative 15y. And that's equal to 3 times 10, which is 30. And so now we're kind of left with this system of equations. And I have a zero pair in the x's.